Hello, my name is Andrew Weaver. I'm from New Earth Healing Center and NEHC Academy. In our healing center, we focus on a method that we've developed ourselves called vibration therapy, or in our case, it's New Earth vibration therapy. And that is using primarily this tool here and a weighted tuning fork. This particular one is 128 hertz. And within our method of vibration therapy, we're able to have some pretty rapid, extreme, extraordinary results in some cases from head to toe from all sorts of conditions that you wouldn't expect would be able to resolve themselves, reverse themselves, change a condition as fast and as complete as some of the things that we've been able to do. And I want to talk about why the physics of this particular fork is doing the things that it's doing so that we can continue with our exploration of how this fork can be a tool for healing. So most people usually think of an unweighted tuning fork as something that can be used for sound healing, but we also know these things as a way to tune an instrument. You would have a fixed frequency of a particular fork based off of the length of the tines usually, and sometimes the thickness. And the word tine is basically describing these two things right here. When they're struck against something, they vibrate, and in an unweighted tuning fork, you'll be able to hear the vibration based off of the frequency of this particular fork. And that frequency would tune an instrument, whether it's keys or strings. You're able to take one fixed frequency and tune that instrument, one note to that instrument, and then you'll be able to tune the rest of the instrument based off of now having one correct note within that instrument. So on an unweighted tuning fork, we do be able to hear those notes and those frequencies because they travel outwards and you can hear them in the ear quite well. A weighted tuning fork, you rarely hear the frequencies that are coming off of these tines, and that's because of the weights and the construction of this particular fork. So the physics of this fork, we still have the tines here, and we have obviously some weights on the end of it. There's a little bit of a difference between the way the two forks are constructed, because in a weighted tuning fork, you want all the vibration to come down here to the bottom, because we're actually going to strike it and place this tuning fork on the skin to have something happen within the physiology of our body. In our case, we're actually changing fluid pressure. Sometimes fluid, interstitial fluid, different fluids within your body actually gets compressed, or it gets quarantined within fascial membranes, and we actually feel or palpate for those particular areas of the body. And when you put the tuning fork on it, there's a physiological process or a reaction that happens within the body to allow that pressurized fluid to release through that membrane. So the reason that happens is because of the physics of this fork. Now, this fork is 128 hertz. This is the one that we use primarily within our healing center, and we do not use any of the other fork frequencies for a very good reason. I'm going to explain that here. There are three main sections to this fork. We still have our tines right here, the weights down at the end, and then this section right here is called the yoke. This is where things get combined together. The word yoke, we usually think that two oxen would be tied together with a device called a yoke, and it just allows two things to be combined to do the work more than each individual thing by itself. And then we have the stem down here, which is actually, in my opinion, one of the most important things about this particular tuning fork. Most tuning forks are constructed like this. This is an aluminum alloy tuning fork, and there are different types of tuning fork metals in different ways they're constructed, but mainly, especially in a doctor's office setting, medical grade tuning forks, you're going to get something that looks and is constructed quite like this. So 128 hertz, what exactly does that mean? Well, the length and the thickness of this particular fork, and since it's weighted, then the weights are also going to be adjusted so that when these two tines are moving back and forth, they're going to be running through an entire cycle of bending inwards, going all the way outwards, and coming back to the same point. They will cycle through that 128 times per second. That's also called cycles per second, which is also called hertz. And that's what we know as a frequency. And usually the frequencies are stamped right here on the yoke. Now, what happens when I strike this particular tuning fork? And in our method, we actually strike it against our hand. It makes this particular tine start to move back and forth. And the yoke part of this, this movement, actually I'll talk about this top one here. The physics behind the tines themselves is that you have a flexural movement. If you were to take, let's say, a ruler and clamp that ruler down to a table and then hit it, the flexing of that particular ruler is going to start what's called a flexural vibration. Well, that's what's happening with this top tine here. And the mechanical vibration that's traveling by flexing is going to travel down into the yoke. Just like in billiards or pool, you notice that when you bank a pool ball off the side, it's going to actually go in a certain direction. There are Newton's laws of motion at play here because this is a mechanical vibration. Speaking of Newton's laws, you may have seen these before. This is a Newton's cradle, and it's showing you the laws, Newton's laws at play here. We would expect that a ball, which would be just like a molecule of something that actually has weight to it, when I let go of this ball here, I'm able to transfer the energy from one ball into another ball all the way to the end. The reason why this really expresses or shows Newton's laws is because if we think about what's going on in the tines here when we're flexing or striking this particular tine, it's taking the molecules, just like the balls of the Newton's cradle, and it's moving them or striking them. When I'm striking the Newton's cradle, you may notice that these balls aren't going anywhere because they're attached to strings. So molecules, whether they're air, water, metal, or our body, the molecules in our body, those molecules don't actually move with the wave of vibration as it travels outwards. They actually just kind of wiggle in place. And notice also that this thing is in a straight line. So when we expect that there's movement of vibrations or movement of molecules, they're hitting each other and moving, and we get up most of our movement in a straight line like this. If you ever hit a pool or billiard ball at an angle, you're going to get the movement to go into a different direction. And really what we're looking for is anything that is in motion, continues with motion, unless acted upon by an outside force, and we start to lose all that energy. So what happens here is you get that vibration traveling down here. Notice the angle of the yoke right there. And you can imagine if this was a pool ball, it would bounce off that edge and go to this edge and travel this way. So when you strike one side of a tuning fork like this, the other tuning fork tine actually starts vibrating as well. And how that is possible is because the construction down here and these banked walls to force all that vibration up into the other tine. It's not actually the air in between here that's pushing them. If that was the case, then they would actually be pushing away from each other and they wouldn't be exactly in sync with each other. It's actually the vibration traveling through the yoke going to the other end. So that sets off a chain reaction here. You've got tines that are flexing now, and they're flexing towards each other at the exact same time, back and forth. Now, one of the other things that's happening here in the yoke is that you've got two movements here of the tines, and they're actually like a funnel. They're funneling all of their movements in sync with each other. They're funneling it down here to the opening of this particular aluminum rod. The reason I call it aluminum rod is because you've got three different things happening here. This aluminum rod, the vibrations in the tuning fork enters into longitudinal waves when it gets into the rod itself. And you can anticipate maybe you have to consider that when molecules, like molecules of metal, when they're traveling down confined spaces, that air and the edge of this particular aluminum rod, vibrations actually will continue to bounce off of the rod itself rather than necessarily going out into the air. They're different. They're compressed differently here. So the vibration is going to go down this rod. And there are demonstrations that you can find on the internet of what's called the singing rod. So if you actually look for or search for a singing rod experiment, you'll see that they actually do use aluminum rods, but they're much, much longer, which brings that vibration down into below 20,000 hertz, which is inside of our hearing range. The size, the dimensions of these aluminum rods, when they vibrate in a longitudinal form, all the sound comes out of the end, and the size of the rod, the length, and the diameter of it is going to determine on what the note is that comes out at the other end. What is the frequency? So the 128 hertz of these flexural vibrations are only feeding into the one end of this aluminum rod, and the frequency that comes out of the end of this is based off of the size, the length of it, and the diameter. So in one experiment that we see on the internet is a professor that actually had taken one rod and clamped it down, and they're using measurement. I think it's a laser measurement on one end to measure what vibrations are coming out of the end of it. And she had taken a tool, a metal tool, and struck the end of the rod to get it to vibrate. This is very much like what's happening here. If you think of the Newton's cradle, when I pulled one of the balls away and it hit the first or the second one, that's what's happening here. The vibrations are hitting each other. The molecules are hitting each other and then striking the end, which starts a longitudinal wave, which means that one ball is striking into the next and continuing all down through this particular aluminum rod. Why this is important is because the frequency that is coming out of the end of this stem is going to be the exact same frequency no matter what the frequency of the tines are. As long as the same length and diameter of this stem is the same, you're going to get the exact same frequency out of these forks at the base. It's measurable. We've done that here with our own measuring devices. It's a very easy thing to do if you have some good quality equipment, and you can tell what the waveforms and the frequencies are that are coming out of the end of this. What we ended up measuring is, of course, we can measure what's going on with the tines, but we actually measured a frequency, a very loud frequency, coming off of here above 20,000 hertz, just above it. Now, what's the significance of 20,000 hertz or above it? The physiology that occurs with certain mechanical vibrations, we usually consider those to be done in a medical setting with ultrasonic equipment, ultrasound. We usually think of ultrasound as a diagnostic tool, but they're also being used for therapies as well. And those particular ultrasonic, the paddles and the equipment, it's producing vibrations within the megahertz range or the kilohertz range. They're very powerful. And when we have frequencies that are that high, we also have an amount of power that's pretty high as well too. And the therapeutic settings for those can be anything from fat reduction, because in ultrasonic range there's a physiological process that happens called cavitation or jetting. These are things that could be looked up as you do your research, and we're going to provide you with links as well. So cavitation is something that occurs when there's mechanical vibration in the tissue where there's fluid present. I was in the United States Navy for 22 years, and that was one of my areas of expertise, and my area of focus for those 22 years is sonar, which is sound navigation and ranging. And cavitation that happens underwater as a sound source is its own source, because the cavitation that we're picking up as a sound source is the popping of the little bubbles that come off of the sides of ships, the propellers, things that are moving through the water. So cavitation is a very well-known and very measurable thing, and the producers of sound, but that's not really what we're going through here. We're looking at the fact that when something vibrates at a specific frequency, and we know that to be in the ultrasonic range, then you get bubbles that form near the edges of membranes. And when those bubbles start popping, the cavitation of it, the membranes themselves, the holes in the membranes, because membranes actually can bring things through the membrane, fluids through the membrane. It's more of a filter, but the size of the molecules that can pass through them are determined by the size of the holes in the membrane, just like a sieve or a colander. And we can even see this with cells. And if this was, let's say, an adipose cell, we would have fluid lipids on the inside of this. And if I was to vibrate the fluid and the interstitial fluids that is on the outside of this, the membrane that is on this adipose cell or fat cell would actually allow things to release. The fluid would be able to pass through this membrane. That's actually what's happening with these tuning forks. When you strike a tuning fork, and I know the size is not the same here, but once this tuning fork with the ultrasonic frequencies coming out the bottom of this fork, when it presses against and vibrates against membranes, fluid is allowed to move through, at least where the vibration is present. We have this on video. We did our own studies on cow material. We're able to show that when the tuning fork, you can see the bottom of the tuning fork, it's magnified with an endoscope up to 4,000 times. And we're actually able to see that the fat from the layers, deep and superficial adipose layers from cow tissue, you're actually able to see the materials from the lipids from inside the fat cells escaping. And that's something that we expected. That's something we thought was happening. We actually caught it on video, and we've got some still shots that we can share with you too. So I'm just talking about adipose cells right now because that's the most common thing that happens with the ultrasonic devices. Now remember, again, those ultrasound paddles and the equipment themselves, they're pretty high frequency and pretty high powered. So you have to be careful on introducing that much vibration to human tissue because anything that is vibrating through mechanical energy, there's a lot of friction involved there. And the heat, if it's too much heat, then you can damage the tissues. So you have to be careful with that. For that reason, these ultrasound devices that are used for therapeutic purposes are either used to heat the tissue and get some results there. Usually it's fluid release just like the fat tissue, but it's not always that. Sometimes it's used for pain relief as well. And depending on how the equipment is cycled, meaning it turns on for a certain period of time, it turns off for a period of time, that allows the heat to dissipate in that area. And then the settings of that equipment matters as well. They're also using it for things like where they do expect and want a physiological response where they're burning and killing the cells in a focused area. I can actually focus the cone of that ultrasound device into a specific location within my body, so that it actually starts to burn or kill the cells from the inside out. Very useful in things like for cancer, for killing cancer cells. So these devices exist. The reason I'm talking to you about ultrasound as a therapy is because it's the same physiological process. It's something that you can read and do and study on. And then there's the concern with the power that comes from these ultrasonic devices. We know that when vibrations get to a certain range, in the ultrasonic range, then we have this physiological response of cavitation and jetting, and there's a lot of studies that have been done in that area. So why that's important is because the length of this particular stem is enough to bring it up above the 20,000 hertz. We have it measured. We know that that happens, and that's what's happening with our therapeutic method. And we can palpate and find the fluid pockets. And the reason why we know exactly where to put the tuning fork is because we've trained ourselves to understand where the fluid is being pressurized within the body, and we have studied this for quite some time. And the fluid pressurization has a component there where pain and mobility restrictions and problems within the body, certain conditions, is all tying back to fluid pressure. And we usually think of that as inflammation or edema, and it's actually quite rampant throughout the body. And when we put the tuning fork on it in a certain way, when we hold the tuning fork, strike it a certain way, put the tuning fork in a certain spot based off of palpation, we can get extraordinary results. What we're really doing is reducing or relieving the pressurized fluid so that it can go back into the drainage process that's been halted because you have basically your drainage or lack of drainage is what's causing most of the problems that we're seeing. So we use this tuning fork to do that. How far down you press into the tissue matters because there's the physics of the vibration. Being able to stretch the fascial membranes on just enough to allow that cavitation to have the fluid move through those membranes is pretty important. So that's what we do in a nutshell. There is some science to it, actually a lot of science. We can prove what it is that's happening, and you're going to see other videos from us to be able to talk about some of the different methods or techniques that we're using, and even more on the science. But we're really following the fluid, and we're following the pressurization process, and it's a lot more than most people think it is. It's causing a lot more problems, and we have a lot of case studies, a lot of examples to talk to you about that we've been able to do some pretty extraordinary things within the Healing Center.